Hi there, John Bishop here. I'm with my good friend, Dr. Nancy Flournoy, and a few friends on tonight. Hi, Virginia. Hi, Philip. We're going to start this meeting. Oh, we got Jill coming in as well. And so I'm just going to let Nancy give a little introduction of herself before she starts this presentation. So take it away, Nancy.
Thank you, John. Thank you for hosting.
And if the rest.
You went on mute, John.
Yeah, if everybody else could mute like I'm doing right now, thank you.
So I'm Dr. Nancy Flournoy. I have a PhD in biomathematics from the University of Washington. I've spent my career developing clinical trial methodologies, statistical methodologies for the design and analysis of clinical research. And so I've had a lot of exposure to a lot of different sciences, but I must say that learning about these patches has just really been a lot of fun because so much has happened to basic biology since I paid a lot of attention to it. And I have enjoyed each and every presentation that I have made up for you all. And I hope you enjoy this one on the Lifewave patch Carnosine. So I assume you've got it so I can share my screen.
Yes, I do.
So can everybody see this properly?
Yep, we can see that, Nancy.
Let me start the show. So this is a picture of what they call a sleeve, the little package that Lifewave puts their phototherapy patches into. And the phototherapy patch at size is shown here in the corner. Well, I don't know if it's at size, but here's a ruler down below it. And what they, there is a lot of regulations about what they can and can't say. So what they have their approval from their lawyers to advertise about this particular patch is that it's shown to increase stamina by 125%. It improves strength and flexibility. It improves overall health. It improves bioelectrical properties of organs. We'll talk more about all of these. And it is a patented form of phototherapy. No drugs, no chemicals or stimulus go into the body when you use the Lifewave patches. So first, by way of introduction, I will say that Lifewave has a whole batch of different kinds of patches that are good for different purposes. And that if you missed my overview talk, it can be found at this website like lightpatchscience.com or on my YouTube channel. And it covers topics like how light makes things happen in the body, different models of aging. It discusses I discuss on that talk, crystals, because the patch is actually a liquid crystal, the effective part of it, and some aspects of electrical conductivity in connective tissues. I talk about biocommunication systems, the nervous system, the connective tissues, and the meridians, and the Bohong ducts that run through the meridians. And then I give a brief introduction to each of the different patches. So we have been talking about the Y-age patches, which Carnosine is the second one. We talked about glutathione in my last presentation. So these crystals on the Lifewave patches absorb body heat, and in turn, they emit light frequencies back into your body. And they, in this case of carnosine patch, it signals the body to increase carnosine production. So we carnosine is, so first, so the talk is organized like this. First, I'm going to talk about carnosine, the molecule, and what we know about it, what we know about carnosine and what it does. And then what we know is that the light waves on these patches are designed to stimulate the production of whatever David Smith, the CEO, designed them to target. And so we have his knowledge of the light frequencies of the molecules that he's targeting to design the patches. But then there's another step which involves research actually on the patches to see what they do. And that, of course, is limited by the equipment that one has to take measurements on the patches. And also it's very expensive. So one can put these two pieces of the talk together to get an understanding as to what one might expect from the patches. So as I say, it's been a great deal of fun doing this research, and I hope you join me in this exploration. So as I said on this slide, carnosine is sometimes referred to as the longevity molecule. And that comes in reference to this fact, this thing that's called the Hayflick limit. And this theory about, this fact about chromosomes and theory about longevity was developed by Leonard Hayflick in 1961, when he demonstrated that human fetal cells will divide about 40 to 60 times in culture before they just go quiet and don't do anything anymore. And this translates in our bodies to about 120-year maximum human lifespan. So the race is on to protect the telomeres. And I say protect the telomeres from shortening, because if we move over here to the left, you can see that what happens if you start here with a nice chromosome pair, these telomeres are the caps on the end, and they're protecting the chromosome. And each time the cell divides, so it splits in half, and it splits in half again, and it splits in half again and again. And each time it does this, you see a little bit of this cap gets destroyed. And through this cell division, this is the shortening of the telomeres. And when it's gone, the telomeres no longer, the chromosomes no longer divide, and that cell has had it. We'll see how this relates. Well, over here on the left, I have that carnosine has been demonstrated to reduce telomere damage and its shortening rate in cultured normal fibroblasts. I've got a train going by, so pardon me if you can hear it. So carnosine, the molecule, has this connection to longevity, and that it protects your telomeres. Now, this is the molecule up here on the left, and it's a combination of two different peptides. And sometimes when the peptides get linked together, you can kind of mark out, one little section. This is the peptide 1, and this is the peptide 2, and they're just stuck together. But in this case, we have kind of the one peptide has its pieces on either end, and the other peptide got kind of squished in the middle and lost some. So it's really not easy to point out what piece of the molecule is which. But it's formed of these two amino acids, beta-alanine and histidine. Now, remember, we have 32 amino acids in our body, and some of them we can make, and some of them one has to get externally. Some of them you have to get externally. When you have to get them externally, they're called essential amino acids. Excuse me. Carnosine is widely distributed in tissues, so you find it pretty well scattered throughout the body. But it's most naturally in the brain, cardiac muscle, stomach, kidney, olfactory bulbs, and in large quantities in skeletal muscle. So one thing about the brain here to notice is that carnosine is this little tiny small molecule that just has 2 amino acids in it, and it can get across the blood-brain barrier. So it can go in and affect things that, remember last time we were talking about the carnosine molecule. It's this great big molecule, and it's not going across the blood-brain barrier. It may be the biggest antioxidant in the body doing the bulk of the work, but it can't do everything, and it isn't designed to do everything. So for some things, we really want carnosine. So in particular, if you take supplements of carnosine, most of it that is absorbed in your gut is destroyed in the bloodstream. And so there's an enzyme there that splits the carnosine back into its 2 pieces. So you end up with alanine and histamine. And now it is possible for your body then to put them back together again, but all that involves work. And, when your body gets old and tired, it's maybe not so interested in doing all that work. Now let me show you the back here to this little picture of the molecule. We have remember the little lines here. Every time there's a little change in the line, there's a carbon molecule that nobody ever writes down. And in our human molecules, we essentially have these long strings of carbon with these various things hanging off of it, like hydrogens and nitrogens and oxygen. And in this particular case over here, we have what's called a ring because it goes around in a circle. And where you have 2 lines, it's called a double bond, and that means it's extremely tightly held together and hard to change into anything else. And so what I'm talking about on the next slide is what the benefits of this particular little ring are. And that's called the Imidazole Ring. And it's responsible, we'll talk more about each of these in a minute, but it's responsible for photon buffering, metal ion chelating, anti-glycating, and antioxidant properties. So just to touch on a couple of those, so one of the things it does is buffering, and pH buffers, which it is, are they're essentially water solutions that can resist changes in pH when you add to them either an acid or an alkali. So acids are acidic and alkalis are bases. And when you put one or the other into something, you change the pH, like in a swimming pool, too much chlorine or too little chlorine. You want the pH to be just right. Well, carnosine can act, like the swimming pool guy that comes in and adds a little bit of this and a little bit of that to get the pH just right. And these buffers are usually a combination of a base and an acid, and they absorb excess hydrogen atoms so that the pH in the solutions in your body remain stable. Now, one thing that this buffering act does, is delay muscle fatigue. And so I'll talk more about that in a minute, but it's one of the reasons that carnosine has become a supplement that's used heavily in the sports industry to keep people's stamina up when they're running marathons and such. Now, there's a whole variety of very interesting different properties. So this ring on the carnosine molecule acts as what's called a chelating agent. And that is something that can bind to metal. And that makes it very valuable as acting as a detox agent. So if you have some heavy metal or other things, other metal molecules in your body that really shouldn't be there, carnosine can go in and capture them and dispose of them. Here's the little picture about free radicals and antioxidants. And so free radicals, we hear a lot about in all of the, you hear it everywhere, that we don't like free radicals and that we need antioxidants. So free radicals have these pairs of electrons, except one of them gets unpaired. And then it's like taking the battery in your car and taking one of the cables and taking it loose and just letting the wire, float around while you're driving. And that wire is hot, electrically hot, and it's going to bounce around and create sparks and maybe damage something. And that's not what you want. And so here comes along the antioxidant, and it's got all of these electrons, and it's the great giver of electrons. So it passes an electron over and gives it to the free radical, and then the free radical is not a radical anymore because it has all of its electrons paired up. So those are some of the things that happen with this ring. Now, carnosine is best known for its function as an antioxidant. And we talked about glutathione in my last talk, and how it helped protect. If you look at the little picture down here in the bottom, it helped keep the free radicals from being so extensive that they caused what's called oxidative damage. That's like when your banana turns black, and it results in damage to the lipids and the proteins and causes tissue injury and inflammation. So that's the general setup for how free radicals cause what's called oxidative stress. But we have a lot of specific things here to note for carnosine that are different from glutathione. So I've already mentioned that the health practitioners have, I mentioned the health practitioners with respect to not the health practitioners, but the athletes have gotten a hold of it with respect to its prowess for helping muscles. And then the health practitioners have got a hold of it with respect to these other features. So we just talked about free radicals. These are some big words, so just read them, let them roll over your head, and don't get uptight about them. It's an effective scavenger. What's a scavenger? It's going to go around and get these things and get rid of them. And the worse they sound, the more you want this molecule to go scavenge them. So it's going to scavenge reactive oxygen and reactive nitrogen molecules and aldehydes. So those are toxic, very toxic compounds that are made in the course of your body doing things that it does naturally. In the case of aldehydes, I put this little comment down here in the corner. Highly reactive aldehydes are derived from oxidative and non-oxidative modifications of sugars and lipids. And that's one thing that's interesting about this particular molecule, is that is its relationship to sugars, which I hadn't really thought about much before, and we'll talk about more in a little bit. So, so it is able to work as an antioxidant, reducing oxidative stress in neural pathways. So it has this relationship to the brain and the nervous system that other antioxidants don't. Now, this is another long sentence, just let it wash over you. So it protects against this these agents that degrade polyunsaturated lipids. So we all know about polyunsaturated fats, and when they oxidize, they're going to degrade into this horrible compound called malondialdehyde. So, I mean, it sounds bad enough, and it's certainly got too many syllables. But what this thing does that we don't want is it contributes to atherosclerosis, joint inflammation, cataract formation, and it's believed to be involved in the cellular toxicity underlying Alzheimer's and autism. So this thing is really nasty, and we want all the protection from it we can get. And carnosine is in sufficient amounts is there to provide that. There's also some reports that carnosine will relieve forms of macular degeneration and protect against glaucoma. So all that sounds pretty good. And then, with so many of these compounds that have anti-aging properties, the people that are interested in marking the compound just really have to tell you how it reduces wrinkles and reduces scars and blemishes, because they think that might be their biggest market, I think. But I almost dropped this off because it seems so petty compared to the other things I've just mentioned. Now, I should say, look over here on the right, that a lot of this evidence about what carnosine does and doesn't do is from small sample animal studies. So, on the one thing, you learn all these wonderful things, but then you realize that the connections are kind of all, very tenuously held, and you wish that they would do some more comprehensive studies, particularly on human beings. But we'll see what some of the limitations are to that when we talk about the studies that have been done on the patches. So we're going to expand on some of these items we just discussed. So carnosine as an anti-glycating agent. Well, what in the world does that mean? Well, glycation is this process, where a sugar gets linked to a protein or a lipid. Now, I hadn't really known that happened before. That is, you have a lot of proteins in your muscles, and
Can you try it?
Do you really want sugars tied up with your proteins? It doesn't seem right. Although what we hear is that the sugars that will do this are glucose, fructose, and the derivatives from them. And that if you have poor blood sugar control, you're going to get more glycation and prematurely age. So what carnosine does is work against that process. It releases the sugar molecules from the proteins and allows these molecules to return to their natural state and shape, where they can do their natural functions. The sugar can be used for energy, and the protein can be used for, building muscle or performing other functions we need it to, structural functions we need. Note that glycation is increased in diabetics, and among the primary causes of cataracts are glycation of the proteins that naturally maintain your lens, the lens of your eye, in a state of crystalline clarity. So this starts to explain a little bit of what connects that long list of things I read that carnosine helps with. So now it's also anti-glycosylation, which sounds almost like what I read on the last page, and it's actually just a generalization of that. They talk about glycosylation creates these abnormal cross-linked oxidized products. So by cross-linked, it means to, proteins and other things. So you get these molecules that aren't supposed to be combined and tied together. And this causes extensive damage to collagen, leads to poor metabolic regulation and unregulated blood sugar levels, and is a precursor to diabetes. So carnosine supports the process of protein metabolism by blocking this, when it can, when there's enough of it and it's where you need it to be, as well as the cross-linking of proteins, which is not good for them to be mixed up together. So that's pretty neat. Carnosine works as a chelating agent, and a lot of people who've done detox at home know that word. A chelating agent is a chemical compound that gets together with a metal, and carnosine in particular protects against copper and zinc-induced neurotoxicity. And then I just added a few things here rather than create separate slides for everything. It's been used to treat patients after stroke by reducing glutamate excitotoxicity. I guess your glutamate's not supposed to be excited. Carnosine has also augmented Parkinson's drug use to improve its efficiencies, and I cite some references. So now here is a page on carnosine as a protein buffer. Again, this is better studied than a lot of other functions that we've seen because of the financial incentive of the sports industry. So what happens here? When do you need carnosine to work as a protein buffer? So what happens is when your energy demand gets close to or in excess of your oxygen consumption, there's a contribution to the energy supply from anaerobic glycosis. And what that does is produce a lot of lactic acid and a lot of hydrogen ions. So now in your muscle, you have, the lactic acid, which I guess, which runners, which makes you not want to run as much. And all of these extra hydrogen charged hydrogen ions. And if you get too many charged hydrogen ions, it changes your pH, so the muscle isn't at the acidic level that it's supposed to be, and it interferes with the muscle's ability to contract and its metabolic processes. So this is where you want to buffer that hydrogen, the hydrogen charges, and that can be done with carnosine, which is inside the cell. And outside the cell, it can be done with bicarbonate, which is baking soda. So if you were going to take a supplement, you might mix your bicarbonate with your carnosine supplement and mix them together and take your supplement. So then it's going to enhance your resistance to fatigue and improve your performance. Now, a lot of these products that are sold as, for the sports industry work really well for sick people, because what they're doing for the healthy person that has exercised to some extreme is the way the sick body the sick body has those kinds of needs without doing much, because the sick body is just exhausted from trying to get well. So when I read about what these different molecules and products will do, to make me the athlete of the year, I wrap it in this other story of, I want to be the healthiest person from where I am, and this molecule is going to help me do it. And I don't have to have that sports image in my mind at all, although you're welcome to have it if that's where you are. So, I don't know, maybe I bore you, but I found it interesting to see how carnosine is also known to help with inflammation and heart function. And so I have this page that gives a little bit of a feel for what it's actually doing with respect to inflammation and heart function. So one thing, when your heart contracts, when your heart fails to contract, it causes morbidity and mortality, particularly if you have, heart disease or you have some inflammatory disorder like sepsis. And research has indicated that this contraction failure to contract is when your muscles, when your heart is pumping, is associated with a failure in the regulation of calcium levels, particularly calcium levels in a molecule called a monocyte, which is a large white blood cell that goes around and ingests and gets rid of bacteria and carbon and dust. And so you want your monocytes healthy. You want them going out there scavenging all this garbage for you. And you don't want your calcium levels messed with if that's going to mess with your monocytes. So while the scientists were looking for mechanisms to explain, why the calcium regulation got messed up when one had ischemia or sepsis, they found a new role for carnosine, is that it in fact regulates calcium inside cells and the contractibility of myocardial cells. So carnosine has been shown to improve contractions in isolated rat hearts and to increase free intercellular calcium levels. And this is from this paper by Dr. Zaloga and his collaborators. And he is saying back in 1996 that carnosine represents a new intercellular message system for the regulation and modulation of intercellular calcium. And now we have a little bit of understanding about why we should care about that. And then over here on the right, there's some results for some clinical studies. It's known to lower blood pressure and protect cardiovascular health. That's kind of the overview statement of the details that I just went over with you. It does so much. I mean, so in protecting against improper inflammation, it's also involved in wound healing. So Carnosine, again, is composed of two molecules. One is beta alanine that's down here, but carnosine can also make histamine. And histamine is known to enhance the process of wound healing by stimulating effusion at the initial stages of inflammation. So, when you get hurt and there's kind of this gushy fluid around your injury that is being brought to you by carnosine being turned into histamine. And then there's this beta alanine that also comes from carnosine, and it accelerates wound healing by stimulating the biosynthesis of nucleic acids and collagen. Now, we've seen carnosine does this and that and the other thing. Well, it also increases what's called granulation, which is suppressed by all these drugs, including cortisone and other things. So if you're on these drugs, carnosine is a good supplement. But in terms of wounds, the granulation tissue gets laid down, and then the body builds a network of blood vessels through it. And carnosine helps with the laying down of that tissue that is going to be the new structure. So over here on the right, then I have that it's recommended for inflammatory conditions, headaches, migraines, gut, irritable bowel syndrome, etc. And now we're getting exhausted because it's doing so much, but it's got an antibacterial function. And I couldn't help but put this on because I have step siblings in Belize, and I got a call from them one time saying, what do we do about one of the children that had been diagnosed with this particular bacteria? And I had gone to I had gone and researched it and found that they should be taking carnosine. And so I had come across this before, and I was very surprised to come across it again. So that's what, as best as I could, lay out an overview of what is known about what carnosine does, a little bit below the hood, not just saying it helps with your heart, but trying to give a little bit of flavor of how it helps with the heart. So now we're going to talk about Lifewave patches. And again, the patch is designed to increase your carnosine levels. And so you've just seen everything that one might expect to flow from that if there's nothing blocking it or tearing it apart otherwise. But we can, we can only study what we can measure and what we can afford. And so we can still do some things. So they've been found to improve organ function. There is a piece of equipment called Electro Interstitial scanning system. And I think I have something on that on the next page. Yes, so I'll talk about the piece of equipment a little bit on the next page. But it measures the impedance of electrical flow through your body. And in particular, one can analyze the flow of electricity through the organs and see whether they are, quote, normal or not. They did a large study on normal people. So they sort of have, these ranges, and you can see whether things are in range or not. So they took 20 volunteers and they patched them 12 hours a day on alternate days for 2 weeks and tested them weekly. And this probably should have gone on the in the earlier section, but it comes here now. I talked a lot about supplementation, but what we see here is what happens with carnosine in 2 weeks that you would see with oral supplementation in 1 to 4 months. And what you see is this whole list of the whole list here, both in green and in black, are the organs that they studied. And the ones in green are the ones that improved significantly their electrical flow in this 2-week period of time. So and why the right kidney and not the left kidney? Well, I mean, maybe the left kidney is just slow, or the sample size was too small. We only have 20 people. But you can see that a whole lot of organs are improved in terms of their electrical conductivity, and a few were not. Now, just, I don't think I'll go through all of this. You can come back and look at it if you wish to. But a piece of equipment is a medical device, registered as a medical device in Europe and the United States. They can scan your whole system in 3 minutes, so that didn't take time at all. The real significant thing is that they're measuring low voltage signals. So most stuff in your doctor's office is done is when you put Electro, you're measuring your, when they put the electrodes on you to measure your heart or your brain or this or that, they're measuring much higher voltages. And they talk about subtle frequencies. We want to catch things that are wrong in the body before you're actually on your deathbed. And a lot of what we're talking about as, are really below what your doctor would find in your office to deal with. So I've said most everything, I think. So in addition to the conductivity, it measures pH, body composition, and the sympathetic and parasympathetic influences of the autonomic nervous system. That's relevant to one of the other pieces of research we're going to see. And that's all I'll say there. So now we have this other study that involves 10 healthy subjects, and they tested 12 different measures of strength and endurance. Again, that's something that's not invasive. It's fairly easy to do. And so it's one of the things that got done. So it's pretty impressive that you take all these different measurements of strength that, doing things like sit-ups and bicep curls and things you might do in the gym. And over here on the right, you have a list of p-values, and the standard kind of acceptable scientific threshold is 0.05 for establishing that, in fact, there was an effect. What the p-value measures is the probability that if you go claim you'll claim a difference, and there really wasn't one. So virtually everything you can be assured that virtually everything changed with high probability, except here push-ups. I don't know, they don't look too, the number for push-ups is not very impressive. And bicep curl repetition to failure, it's just above the magic cutoff level, but it's a magic cutoff level. So in terms of the Sports industry, it looks great. And if you are interested in flexibility, strength, and endurance from whatever level of health you are, I would say that that would be reason enough to try your carnosine patches. Now, the third study here is looking at mental decline due to glycosylation. That's where these molecules, sugar and other things, get mixed up together that shouldn't be mixed up together, and then they kind of just gum up the works. So they had this standard battery of tests that's called the microcog, and it measures all these things that are in this little table in the middle. So lots of different mental functions. And they also, in addition to them, and again, we are interested in the mental functions because we know that carnosine is going to get through that blood-brain barrier and has the ability, therefore, to help your mental processes and everything associated with what goes on in the brain. And so that this study had two pieces. That was one. The second piece was to look at the balance between the sympathetic and parasympathetic systems in your nervous systems. And they had a particular scanner and a code system by which they did that. So you don't have to look at this whole table here, but this is the results on the mental cognitive testing. And on the left-hand column, we have these different listings of the subtests that were involved. There was a treatment group and a control group. So you have the pretest means, treatment, and control. And what you want to know is that before you do anything, your treatment and your control should look virtually alike, because you want to see whether one changes and the other doesn't. So you'd really like them starting from the level playing field, and the treatment and the control groups do look pretty close to each other. And then after the patching, where the controls had a patch, but it didn't have any crystal on it, one can just eyeball this and see that the controls look pretty much like they did before they were patched, and the treatment group looks, everything is higher. And so they calculate the difference for the treatment and the control, the differences for each, and the differences, and then they do a test on the differences of the differences between the treatment and the control. And again, we're looking for low numbers here, which is the probability that if you went out and claimed there was a difference, you'd be wrong if there was one. And let's see, everything is these probabilities that you'd be making a mistake when you make that claim are pretty low. The highest one here is reaction time. But these are some pretty low probabilities. Particularly really low down here are general cognitive function and general cognitive proficiency. So I think that one can conclude, or it seems pretty clear that one can conclude that the carnosine patch is having an effect on, and this is the patch, not just the molecule in some other study. This is the patch. And then I don't think I've included data, but they also had data to show that the parasympathetic activity of the autonomic nervous system increased, and as we have in this table, cognition was improved. So just to summarize the results on the patches, I shouldn't have written carnosine research results here. This is the carnosine patch research results. They've shown that it improves the function of a whole lot of organs. It improves flexibility, strength, and endurance. It increases the parasympathetic activity in the autonomic nervous system, and it improves cognition. And then we can go back to the whole first part of my talk and add in everything else we know about carnosine. And with that knowledge, we know that we can expect much more. And if you want then to hear personal testimonies about people who've taken the patch, and they can tell you about their experiences and what they've noticed for themselves, the Lifewave website, lifewave.com, has lots of testimonials on it. So I need to say that Lifewave products are not, they don't treat, they don't diagnose, treat, or can cure any diseases or medical conditions. They are sold for your general well-being, and that you should contact your doctor if you have any questions about medical conditions. So there's some research that I just mentioned can all be found down here. I mentioned the science section on lifewave.com. These papers are all there for you to read, and some other papers that I referenced in this talk, and many more that I referenced that I didn't get the citations. Forgive me, didn't get the citations written down, but I think I got people's names and the dates of their papers in. There's quite a bit of research in this whole area. And I look forward to seeing you again for my next talk, which will be on the Eon YH patch. So again, there are 3 YH patches: glutathione, carnosine, and Eon. And the 2 that we've now talked about this year are have antioxidant properties and other things as well, but those are big parts of what they do. The Eon, and they're also named after the molecule that is being enhanced. So here we have Eon, which does nothing to do with a molecule, and David Schmidt has let it be known in one of his talks that the molecule that is being targeted is the queen bee peptide. So that's going to be really exciting and fun, because the queen bee is the queen bee. And so for a reason, and that's the peptide in question. So thank you. Come visit me on lightpatchscience.com, and I will turn this back to John.